Hello, I am Dr. J.K. Sachdeva. Welcome to the new series, Non-Parametric Tests. In this video, we will discuss why we need to use non-parametric tests. Non-parametric tests mean where parameter is not available, is it? Let us begin with a simple situation. Imagine you have collected data for your research. You are excited to analyze it. You open your software, SPSS, Python, or R, and you are ready to apply statistical tests. But then something goes wrong. Your data is not normal. It is skewed. Maybe your sample size is small, or perhaps your data is based on Likert scale, strongly agree to strongly disagree. Just remember one video, myths and facts in statistics. We discussed that Likert scale data need not be normal for any analysis. But here we are discussing that if Likert scale data is small in size and it is skewed, then there is a problem. Now the question is, can you still use the usual statistical tests like t-tests or ANOVA? The answer is not always. I repeat, not always, as sample size is small. And this is exactly where non-parametric tests come into picture. Before we understand non-parametric tests, let us first understand the problem. Most traditional statistical tests, what we call parametric tests, are based on certain assumptions. One of the most important assumptions is that your data should follow a normal distribution. A normal distribution is a symmetric bell-shaped curve. In such a distribution, the mean, median, and mode are all equal, and the data is evenly spread on both sides. But in real world research, data is rarely this perfect. You may find that your data is skewed either to the left or to the right. You may have outliers, extreme values that distort the analysis, or your data may not even be numerical in a true sense. It could be ordinal, like rankings or Likert scale responses. In such situations, applying parametric tests can lead to misleading or incorrect conclusions. Now let us take a very practical example. Suppose you are conducting a survey to measure student satisfaction with a course. You ask students to rate their satisfaction on a scale from 1 to 5, where 1 means very dissatisfied and 5 means very satisfied. You collect responses like this: 5, 4, 4, 3, 5, 2, 5, 4, 1. At first glance, this looks numerical data. But is it truly numerical? Not exactly. This is ordinal data. The difference between 1 and 2 may not be equal to the difference between 4 and 5. These are categories with order, but not precise, measurable intervals. Also, the data may not follow a normal distribution. It may be skewed, especially if most students are satisfied. So, if you apply a parametric test here, you are making two strong assumptions. First, the data is interval in nature. Second, the data is normally distributed. And if these assumptions are violated, your results may not be reliable. So, what is the solution? The solution is to use non-parametric tests. Non-parametric tests are statistical methods that do not require strict assumptions about the distribution of data. They are also called distribution-free tests. Instead of relying on actual data values, these tests often use ranks or medians. This makes them highly useful when your data is not normally distributed, your sample size is small, your data is ordinal, or when outliers are present. Let us understand this with a simple idea. Suppose instead of comparing exact values, you convert your data into ranks. For example, instead of focusing on exact satisfaction scores, you rank the responses from lowest to highest. Now, your analysis is based on relative positions rather than exact numbers. This approach reduces the impact of extreme values and removes the need for strict distribution assumptions. Here is simple analogy. Imagine you are comparing the performance of students. One way is to compare their exact marks, but marks may have inconsistencies, different difficulty levels, evaluation bias, and so on. Another way is to rank the students first, second, third, and so on. Even if the marks are not perfectly comparable, ranking still gives you a fair idea of performance. That is exactly what non-parametric tests do. They focus on order, position, and relative differences rather than exact numerical values. Non-parametric tests are widely used in real-world research. They are especially common in social sciences, behavioral studies, medical research, and management research, where data often violates ideal statistical assumptions. So, to summarize, when your data is normal and meets all assumptions, parametric tests are powerful and efficient. But when your data is skewed, ordinal, or does not meet assumptions, or is small in size, non-parametric tests provide a reliable alternative. They are flexible, robust, and practical. In the next video, we will take this discussion one step further. We will clearly compare parametric and non-parametric tests and understand exactly when to use each one. And then we will start with the first non-parametric test, the sign test, with complete practical example. Remember one important thing. Statistics is not about forcing your data to fit a method. It is about choosing the right method that fits your data. Thank you. Thanks for watching, and share this new series with your friends who are interested in non-parametric tests. Thank you.
Always share the videos of Dr. Sachdeva to your friends who are interested in data analysis.